What is brain-computer interface? BCI explained. Imagine being able to control a computer or a robotic arm just by thinking about it. That's what a brain-computer interface, or BCI, makes possible. It creates a direct link between your brain's electrical signals and external devices. Instead of moving muscles or nerves, BCIs tap into the brain's activity to understand what you want to do and then make it happen. This technology is part of a field called experimental and emerging science, which often pushes into controversial areas. Some experiments involve implanting tiny electrodes into the brain to get clearer signals, while others use sensors on the scalp. The signals come from neurons firing, which are tiny electrical impulses. Sensors pick up these impulses, and computer programs decode them into commands. For example, you could imagine moving a cursor on a screen or controlling a robotic limb just by thinking about it. There are two main types of BCIs. The first is invasive, which means surgery is needed to implant electrodes directly into the brain tissue. These give the clearest signals and are often used for medical purposes, like helping people with paralysis regain some movement. The second type is non-invasive, where sensors like electroencephalogram caps sit on the scalp. These are safer and easier to use but produce weaker signals. They are often used for gaming, virtual reality, or simple device control. The process is pretty straightforward. Your brain thinks about an action, neurons fire, sensors detect these signals, software decodes them, and the machine responds. This can happen very quickly, almost instantly. From a weird science view, BCIs are fascinating because they blur the line between human and machine. Some experiments even aim to enhance human abilities beyond natural limits, which raises questions about identity and control. For example, some researchers are working on devices that allow controlling drones with thoughts or influencing virtual worlds based on brain activity. These experiments are controversial because they involve invasive procedures or raise ethical questions about mind control and personal autonomy. Today, BCIs help people with disabilities communicate or operate prosthetics. But future experiments might involve more bizarre ideas, like merging human minds with machines or creating new forms of consciousness. In essence, a brain-computer interface is a powerful tool that links the mind directly to technology, turning brain signals into real-world actions. It opens up exciting possibilities but also sparks debates about what it means to be human when machines become part of our neural network.